Good afternoon. I'm obviously very happy to be here, to be back here, and to have the opportunity to meet the newcomer and member of the very fast-growing manufacturing in the age of experience community. Mr. Hay, very interesting talk. I mean, it did demonstrate the way that the digital world can support massive change in industries. And indeed, we do need massive change because we are entering in the age of experience. And in the age of experience, manufacturer needs to deliver extremely complex product, extremely fast, much, much faster than ever before. And that puts a lot of stresses on all of us industrial. I've been visiting a lot of operations lately, and I can tell you, this change is upon us, and it's if anything, it's happened faster than we ever thought. And the issue with that is that, and we heard about Weiwei and others, those are front runners that are already started to adapt to this new situation. And obviously, those who do not move are at risk. So we need to go forward and change some of those major models that we've been used to use in the past, mass production models, diversification models. Those do not perform to the level to which we expect it tomorrow in the age of experience. Let me elaborate a little bit. In year 2000, globally at that point in time, the economy became really worldwide. And as it became worldwide, the market for industrial goods exploded as a lot of newcomers, China, India, Russia, came into the game. At this point in time, the name of the game was to be able to provide product to all those new customers, product at a reasonable cost to start with, and product also at an adequate level of quality. We entered an era of market push, as volume was of the essence. And so manufacturers adapted themselves, and what they did is that they started building to stock very standard product in usually fairly massive but extremely stable organization. Obviously, one of the questions was how to get the machine going and the supply, and so the notion of supply chain emerged, some kind of hierarchical notions of descending flow of information, ascending flows of supply to feed the machines. Product introduction was not really an issue then because the market was not necessarily require a lot of new products. And therefore, at that time, the classical try and error approach was the one that was followed by most of the industry in order to introduce new product on a rare occasion. That was in year 2000. Around 2010, 10 years later, things changed slightly. Because after having purchased for 10 years very worldwide standard products, we, customers, the market, required product which was a little bit more suited to the local or specific needs. The product started to become configurable. And with the product came a set of services to further enhance the value of the product and its usage. And obviously, manufacturing here again had to adapt because as the market switched from market push to market pull, and as the subcategories of customers just increased, not only did the product getting more and more complex, but the need for speed in introduction of new products was rising very significantly. So at that point in time, three things happened. First, obviously the try and error approach was not appropriate at all to try to feed the market with new product. And so this was at the time that emerged the notion of virtual twin, which was a digital sandbox which allowed engineering to converge on the project definition much, much faster than ever before, and hence enhancing the speed of a product introduction. Second, we had to look again about the supply chain, because supply chain, this hierarchical ascending, descending flows, was not agile enough in order to feed those new products coming in the market. And so at that point in time, the idea was, first of all, to have all the actors around the product involved in the famous supply chain, which, and that would include the service people, the person that, or the organization that provided service to enhance the functionality of the product, and to have that set of organization managed in a much more horizontal and synchronized way. This was the emergence of what was called at the time the value chain. And that provided some effect and indeed some speed. And finally, manufacturers also needed to improve. And so they started building to orders and not to stock. And they had to find ways to be more reactive in the workshop. And this is at the time where they tried to synchronize business processes within the workshop, flow of parts and flow of information in order to be more efficient. And that, again, was a very good way forward. And they did indeed meet the challenge of the year 2010. Is that sufficient today? The answer is no, because we don't want to buy products. We want to have experiences. And the experience is to be able to choose our product, to use our product in our own way, in our own usage. And obviously, preset configurations of product and services do not match the diversity or creativity we all have as users. So we need to do something else. We need to adapt again to be way, way more adaptive. The first thing is, we have to reinvent the way we construct this partnership or this supply chain or the value network, or the value chain, I would say, around the product. Why? Because we need to be able to, on the fly, instantaneously, being to adapt this provider of services to the usage the customer wants to do. And hence, we have to completely change the value chain. The value chain is not efficient enough. We have to come to this very adaptive system, which will allow to build value chain, but on the fly for each customer at each point in time. This is the notion of value network, which is today pushing extremely strongly the age of experience, or at least the capability to feed the market with highly customized product. The second thing is, obviously, to be part of the value network, manufacturers also need to adapt. First, they don't need to build to order now. They need to build to my order, which is something totally different. And second, they cannot accept to be just reactive. They need to be adaptive. And to be adaptive, what does it mean? It means that at any point in time, they need to be able to entertain a series of possible options for the future. New options of productions, new options of product, new options of supply base. And obviously, this cannot be done in the Excel file of year 2000. And I would say this cannot even be done with the virtual twin of year 2010, because the virtual twin was built to help the design converge faster, not to explore future. So we have to go to the next gen. And the next gen, this is the 3D experience twin. A holistic, model-based, data-driven twin of reality, which models will allow us to explore future based on real-time data. This is the way we will be able to explore the different options that we have. And this is the way we will be able to pick that option that fits our purpose. So this is the way forward. This is the path to excellence. And we should not wait, because this is available today. And again, the front runners are moving ahead and totally changing the market. We need to be with them. And so let all of us go together along that path and build this virtual 3D experience twin based on the 3D experience platform for all your companies. As demonstration is usually much, much better than a lot of slides, and to further demonstrate to you the value of that approach to answer the challenges of the age of experience, what we've done today for you, and actually for the couple of days that we are all together, is we actually have built a 3D experience twins for you, so that you can experience it and see the value that it can provide. So in the minute to come, let us just go and visit that 3D experience twin and see how you can leverage it to get the speed and agility that the market requires. So to do that demo, what I would like to do is call on stage my colleague that help out building that 3D experience twin, and so that we can guide you in this virtual tour, I would say. So I call on stage Morgan Zimmerman, CEO of Exalead, Rob van Egmond, CEO of Quintic, and Garth Coleman, VP Marketing of Enovia. Okay. So here we are. This is the 3D experience platform. And this is a view of the 3D experience twin we have built for you. So as always, with visiting a workshop, I suggest we take a little tour of the operation here. Okay? So here is the warehouse. Okay? This is where the inbound logistic is coming. From here, the flow of materials goes to the fabrication here for mostly machining and milling. But also in fabrication, you see that that site just got equipped with a 3D printing facility to put some agility in the system. So the part from the warehouse goes to those two fabrication areas, and then the flow of materials goes to here, which is a painting or surface preparation in order to get the materials prepared for final assembly. The final assembly will happen here. This is the big assembly hall where the excavators, I should have started like this, because this is an excavator factory, the excavator will be actually assembled. When assembled, all excavators will go into that big hall over there, the demo hall, in which customer acceptance will be performed for those small series which requires it, and when customer wants to see it, or in any case, it will go there for preparation to transport. You see, this is a sustainable site, and so this site has wind turbines which produces electricity for the sites, and so indeed this is very good from a sustainable point of view. And finally, have a look at here. This is the engineering and the management building, and in here is kind of the nervous center of that site where a lot of decisions are taken. So I suggest we start the tour, and to start with, in the introduction, I mentioned the fact that the 3D experience twin was data-driven. Morgan, can you tell us a little bit more about why data plus smart manufacturing will indeed enhance performance and agility of this operation?
Of course. But let's first go into our boardroom. You're talking about performance. For the avoidance of any doubt, when you talk about performance, you're talking both about the performance of the operation and execution, as well as the performance of the plant itself, every machine, every robot, every resources. To achieve that, which is what you see now on the screen, we've made two breakthroughs. The first breakthrough is a technology breakthrough. We've built in all of the capabilities to manage the semantic of the product to be manufactured, to manage the MES data, and to manage at the same time all of the machine data, the whole of that in the same system. So in other words here, you're controlling IoT, relationship, semantic, all together. The second is more interesting. It's not technology. It's managerial. It's organizational. Analytics is not for executive. Not only for executive. Indeed, analytics is for everyone in the company. Because what we want is we want to make sure that everyone is empowered to drive their everyday decision. But to do that, we need to give them the context. We need to guide them to make sure that when they're taking their decision, they understand the impact, and they're making sure that their decisions are geared towards enterprise performance drivers. So connecting performance with every decision.
Morgan, you just mentioned very briefly IoT. I'm a little surprised because in some other context, I mean, analysts are spending full session totally dedicated on IoT. So aren't we a little bit underplaying that?
That's a very good question indeed. Indeed, you're talking about performance. Performance requires availability of every system. If you want availability of every system, you need to control what's happening in real time. Here, more specifically, we are controlling the real-time data of our wind turbine, and you just seen that one has changed status. So, of course, I can go and see, we see connectors to the OSI soft data, the real-time data. However, this is very, very far from being enough. Because in reality, if you take the IoT data alone, there is not much you can do. There is not much insight you can get. So at Dassault Systèmes, we believe, and we have the very strong belief, that IoT is a must, but under two conditions. Condition number one is we're using what we're learning on the virtual world to better interpret the IoT feeds. So there is no other way to get insight than to be capable of understanding how the system is behaving against the way it should have been behaving. This is how you get insights. This is how you identify weak signal. The second condition is that you actually project as well in the virtual world the whole of the context. What was the maintenance operation? What is the spares which are applicable? What is a nominal purpose for this specific system? So if you have both the context and if you learn from the virtual world, then IoT becomes of great value.
I really think you have a point here. I think one of the big differentiators of our approach is indeed the fact of being able to look at data in context. But I think this needs a little bit deepening.
Yeah, I can give you more insight on what I mean by context, and I realize I've been using the word a lot, and I'll continue to do that. But this is easy for me in your specific context, Guillaume. You have spent far too much time yourself in the factory to accept that people on the shop floor would agree to work just on a dashboard. Because if you want to give them context, you need to give them more context. So what you see now is a virtual representation of our factory with all of the real-time data fully projected here. So you have all of the performance KPI, you have all of the issues, you have all of the behavior. Everything is accessible from the virtual world. The good news is here you have all of the context. There is no more need to provide everyone with the name of the robot to make sure you speak about the same machine. It's obvious, it's in front of your eyes. And by the way, there is an interesting side effect to that. Because this is model-based, and because on top of our data science engine, we have a science engine with modeling and simulation, here we can play what-if scenarios to make sure we're configuring the system to behave the way we want and to model our future.
To the point. So if I understand well, here I'm going to manage my old data, right? So I'm going to be the king in my own castle within the four walls of my factory. But as industrial, we all know that this is not quite sufficient. We need to get open to the outside, and we need to get that data flowing in. How do we do that?
Yeah. I hope that I have not been misleading so far. It is true that in the last few minutes, I have mostly been showing you data that are coming from within the factory. But you're right. Smart manufacturing starts outside of the factory. And more specifically, start by capturing the data generated by the customers themselves. So what you now see on the screens are actually data generated by the customer on our excavators. So this is quality data, this is warranty data. And we've put lots of semantic to be able to match the specific issues to specific pieces of equipment of our excavators. But you know what is complex? What is complex is to connect the dots. To connect the dots between an issue and machine data. To connect the dots between MES and these issues. And to do that, we've made another breakthrough. We're using technologies that was initially developed for cyber criminality to connect the dots, which is what you see on the screen now. So here, this is where the analyst can build his knowledge graph, look at the incidents, connect the dots between all of the data. And while doing that, not only is solving his problem quicker, but at the same time, he's building a knowledge network. This is a capitalization system to make sure that this problem never happen again, one, and should that problem ever happen, that you get an alert immediately. So if I summarize, what we did show in the last few minutes, we did show how we're managing end-to-end performance, from execution to plant performance. We did show how we're using performance drivers and analytics to empower everyone in the factory, everyone in the shop floor, to make sure that every local decision is made geared toward performance. We did show how we're using IoT in our unique manner in the virtual world to get better insights. We did show how we're factoring into it all of the customer experience data. And then, of course, how we're using our science engine to model our future. The whole of that with a deep graph, a knowledge network to do investigation.
Thank you, Morgan. I think it's clear. It's clear that, indeed, we can leverage the 3D experience to be able to take or to do smart decision making, and obviously, getting to the level of performance that we need. Thank you. Other aspects of things, obviously, is around value. So Rob, how can we leverage the 3D experience twin to capture and manage value?
Okay. Thank you, Guillaume. I think just to remind you, all of this data is very important because it drives great decision-making processes. And I think if you want to look at investigating where does value come from in a manufacturing experience, we need to look at where do we actually make the right decisions to deliver that value. And one of those areas is actually in sales and operational planning, or S&OP. In S&OP, we actually manage the demand from our customers versus our ability to supply, and then make strategic decisions as to what demand we want to fulfill and what we may need to do to actually fulfill some of that demand. So we may have to look into our supply capabilities. So let me give you a little bit of an example of how that may work. So here you see the S&OP solution as it runs on the 3DEXPERIENCE platform. You can see that we are not necessarily fully making our revenue budget because right now some of our sales forecasts seem to be low. So we do a collaborative forecasting methodology which is partly driven by algorithms on the platform, but also partly driven by sales and marketing information. And as part of that collaborative discussion, we find out that yes, indeed, our sales forecasts are right now on the low side. So let's, together with all of our stakeholders, increase those sales forecasts for about 30%, so that at least we have a collaborative, let's say, concession based on consensus on where our demand is going. So now we all know where the demand is coming from. And now, of course, the next thing we need to do is figure out, can we actually supply? And again, as part of the sales and operational planning module of the 3DEXPERIENCE platform, we've completely modeled our complete supply chain with all of our factories here, 2 in Europe, in the US, and in Asia, so that we can precisely detail out how we're going to actually manufacture our excavators so that we can deliver that supply. And then we can figure out, are we able to fulfill all of our sales needs? And again, you can see here through the chart that we have a challenge actually living up to that expectation. So we have a bigger demand coming from our customers than we are currently able to supply through our manufacturing capabilities. So let's dig deep a little bit into how do we actually build up the excavators and where do we produce them. And then you can see here that we find out that right now we're short on capacity to build cabins. And given the larger demand in cabin-based excavators, you can understand that if we don't have the cabins, we basically can't create the total excavators. So now we need to start doing some what-if analysis to figure out how can we address this shortage of capacity, because, of course, in the end, we want to fulfill our demand. So we can look into, for instance, extending some of the manufacturing capabilities. We may be able to outsource some of the manufacturing, introduce 3D printing, and all of that will lead to multiple scenarios that we then hand over to an executive S&OP process, where we can make a decision to go for the most profitable, in this case, scenario. And then we've made the decision where to produce what, how to produce it, and we can hand that over to further scheduling.
All right, so yet another way to explore futures. Okay, so that's clear about the way we're going to manage our own capability to produce, and we know what to produce and for whom. But obviously, we have to get the supply base somewhere in the picture, right?
Yes. Yeah, you're absolutely right. So on the one hand, of course, we are looking at combining and looking at the demand from our customers, our ability to supply, but of course, that's not only it. We also need to look at our ability for our suppliers to deliver the parts. Right? And earlier we talked about manufacturing moving from a silo effect to an integrated effect. And I think we need to be aware here that the integration effect of manufacturing does not only contain within the factory walls, but actually it got extended. So as part of the 3DEXPERIENCE platform, we've actually made a number of unique capabilities available to actually create a full value network between us and our suppliers to make sure that we have a fully integrated stack. Some of these features include a full catalog of all different components that our suppliers might provide to us. And let me give you a number, for 100 million. Actually, we have 100 million different parts in our system available for our customers. And it's maybe another important component is actually program-driven. That means that for every individual program you build, you can select which suppliers you want to use and which, of course, you cannot use. A third one is, and as you can see that here, is that it's actually integrated into the authoring tools. So as the designer is working on the design and he comes up to a specific part that he would like to use, immediately he gets in a contextual view of what he actually has available, which parts have been authorized for availability, and which are there right now. And as such, we create, let's say, a secure network where we can produce in a lean and secure, let's say, collaborative way together with our suppliers a full, let's say, a network of providing value to our customers. But now, let's imagine we can go even one step further. Let's imagine that on the 3DEXPERIENCE platform, we have a marketplace where you can actually, let's say, order, pay, and get your parts immediately delivered from those suppliers in your value network. That will immediately make that whole configuration of that network dynamic in the platform and make it so much more fast, expedient, and agile. And maybe I can even, let's say, use my imagination to go one step further. As we have, let's say, availability on the capacity we have in our factory, we can start sharing that production capacity back into the 3DEXPERIENCE marketplace to start sharing that with our value network and thus being a full collaborative part of the value network. Right? So as I discussed earlier, one of the ways we need to achieve value in manufacturing is we need to figure out and manage the demand of our customers, our ability to supply that and manufacture that demand, but also looking at continuously at a dynamic network of suppliers to configure precisely the product that we need for this specific demand.
All right, clear. So I think here we have all the elements to actually be able, with the 3DEXPERIENCE Twin, to manage our value network. We have all the process to capture demands. We have the strategic sourcing part, which will allow us to adaptatively map our supply base, okay? And we have the marketplace on top of that, which will provide us the ability to indeed being able to provide this value network or manage this value network. So clear, the 3DEXPERIENCE Twin is a proper way or the best way to manage the value for us. We took smart decision. We are managing value. Now there's just one thing, Garth. We need to execute, right?
Yes, sir.
So how do we do that?
Well, to do that, we're going to combine the creative theme and the human theme. And let's go right into the 3D printing factory and take a look at that in action, where we're going to talk about driving very good and efficient execution right on the shop floor by not only triggering the execution, but monitoring the result and then optimizing the operation based on real-time information. So here, this is the factory cockpit that we're accessing through the 3DEXPERIENCE platform. And this is showing us our 3D printer factory and all of the equipment that's currently in operation. And we can see the schedule of work orders happening. And you can see there's three similar work orders on this particular part that's being batched right now. And more than just seeing the schedule, we can get the real-time information coming from the equipment. We can see that on one printer, the job is now complete. And in fact, it's in quality control to check the result. And again, because this is real time, as the quality control is happening, we now see it's changed its status and it's now in KO. It's no longer good. And because this is all digitally connected, we can go into that information and dig in to find out what's going on and see, can we resolve this right now on the fly? And thanks to the power of 3D to help us communicate, we can see the quality control person has gone in and indicated there is a problem on the top surface. We can see the notes that they've put in. We can look at maybe pictures they've taken. And clearly, this is a problem that we need to resolve. So we can send out a non-conformance notification, pause all the other similar jobs until we can resolve this, and now go about working on the resolution. And in this case, we need to do a milling operation to smooth out that surface. And we can go and schedule that in the work order. And now we can ask manufacturing engineering to go in and create that machining program for the mill. And because this is 3DEXPERIENCE platform, we can do this no problem. And we can leverage the real 3D geometry, the master geometry. We can set up the tooling and set up the equipment, and then go in and program virtually and validate that actual tooling that we want to do. And all this information can then be connected back into the 3D factory, the printing factory. It can be scheduled into rework to fix that non-conforming part. And once that's been validated, we can update the other work orders with this process so that now everything can be rescheduled real-time dynamically like this. So thanks to the 3DEXPERIENCE platform and the 3DEXPERIENCE Twin and being connected in real time, we're able to drive the operations, monitor them, mitigate the problems that we have, and optimize things on the fly so that we can make sure we have an on-time delivery with a lot of speed and agility.
Okay, all that from the 3DEXPERIENCE platform. So it's clear how the 3DEXPERIENCE Twin will help us execute, right? But so this is more global. This is about the global organization of production, right? But how does the 3DEXPERIENCE platform will or the 3D experience tool will help the people on the shop floor, the men and women that are going to execute all those single tasks?
Okay, so let's do that. Let's go into the shop floor, and we'll take a look where that everything everyone does and every business process that's being followed, the 3D Experience platform and the 3D Experience Twin are going to help with automation to make things much more efficient and much more accessible and simpler for everyone to collaborate and follow up. So one of example here is of the common lean manufacturing practice, which is the 5 minutes meeting to kind of start the day. So here we have, we can look to start our 5-minute meeting. We can say who's here today on the team. So we're all here, but let's, for an example, say, Guillaume, you're not here today. Maybe you're off or you're sick or something, okay? Now, imagine now this information being collected by all the teams that are working and some automated intelligence here being able to collaborate on all of this and give us information as to how might we balance some missing or unavailable capacity and some skills and give us some recommendations. Now, we want to go in and assign people to where they might be working for the day. So I can put Morgan over here. I can put Rob here.
Hey, I'm not here.
I'll put myself here. You're not here. I can't put you here. And imagine, again, with the platform intelligence being able to not only position us here, but go and check our certifications, check that they're up to date, check that we have the skills and the competence to do the work that's being asked of us. Now, also part in our 5 minutes meeting, we want to go in and take a look about what our health and safety was yesterday. And yesterday, we did have a deviation, so we can report that. But the system is saying, wait a second, you had a deviation. You need to take an action. It's not acceptable to leave this deviation here. So we'll take a note and have a follow-up action on that. And finally, in the team, we're looking at our work orders from yesterday, and we can indicate that for this metric. And if we see that there's an ongoing problem, again, we can take an action to follow that up. Now, all of this interaction that we've been doing in our 5 minutes meeting is being tracked, and it's available. And we can go back and see what we have done in previous days. We can close out some of the tasks that are done. This new task in here that we want to work on today, Morgan, I'll have you look into that, and we'll see what's going on. So thanks to all of these capabilities, we're helping everyone in the factory, the workers, the team leads, the supervisors, and providing amazing visibility and traceability to virtually manage everyone and have a very, very efficient shop floor operation.
Okay, this is one instance of lean manufacturing. This is a 5-minute meetings. I guess we can do other instances of lean manufacturing, right?
Of course. We can imagine a scenario here where we want to do some collaborative problem solving, where we maybe have a fishbone type of approach. We want to work collaboratively, do some brainstorming, and again, take some ideas, create some assignments and actions and follow-up. And because of digital continuity and this interface that's easy to collaborate, this is all inside the 3D Experience platform. So there are tasks and actions to follow up by people once we leave this room and go on to our day.
Yeah, so it's not only the 3D Experience will help us drive our operation on a daily basis, but on top of that, it will certainly help every one of us on shop floors to manage our teams and for people on the shop floor to execute efficiently what they have to do. Smart decision making, management of value, providing efficient execution. One last topic, okay? How is 3D Experience Twin helping us innovating? This is an important topic.
Well, there's two elements to your question about innovation. The first question is, how can we use the 3D Experience platform to innovate and explore these new ideas? But then, once we have the right ideas, how can the 3D Experience platform help us execute those and get those completed? So to start with the very first question on innovation, let's go upstairs from the shop floor into the process and manufacturing office, where we'll see what new ideas are being worked on. So here, what you will see is some work being done, investigation to explore a new flexible MRAM cell. An MRAM is a multiple robotic advanced manufacturing cell. And with some collaboration we've been doing with Wichita State University in the United States and the National Institute of Aviation Research, we're working to develop the manufacturing cells of the future. And using the 3D Experience platform, we're able to integrate and program virtually these manufacturing MRAM cells with multiple manufacturing technologies and incredible flexibility, so that one day, in the above example, you are being able to do some manufacturing on a composite fuselage, and the very next day, reconfiguring that so you can do some manufacturing, say, for a wing on a drone aircraft. And this is the kind of thing that at Dassault Systems we are very, very excited to do by working with Wichita State University to train the next generation of engineers using real industrial projects like this so that they can build the factories of the future.
Okay, so this is really about R&D. It's really about investigation of new technology to see how that can help in building the factory of the future, or the future of industry. But in a lot of cases, innovation is not that shiny side of the problem. It's the other one, the one that take an innovation and try to push it through the shop floor efficiently. Can the 3D experience field help us doing that?
This is the second part of the question about execution. And let's go back in the boardroom to do that, because a lot of times there are some decisions made in the boardroom that then need to be pushed to the enterprise. So here we have everything at our disposal to do that. We've got our current excavator product that's in a max configuration. We can see that there's multiple options. There's a couple of different bucket sizes that our customers can choose from. And we can also see that the team has been exploring some new ideas that they're looking at to make a better experience for our customers, to drive into some new markets. And one of the ideas that's coming out is an entirely new attachment to give a new usage of the product. So because we want to be flexible and take advantage, we have access to the digital project plan. We can see that it's still in design. So there might be a chance to actually get this to market quickly. And to do that, we simply take the task that's available, drop it to in-work, and that will assign a task to engineering to go and do an exploration on this. So because we have access to all this relevant information, we can make the right decisions, set up a plan for success, and put that plan in motion.
Okay, this is on the engineering side, right? So what's happening on the manufacturing?
So the manufacturing side, let's go now back to the manufacturing office, where we can see the consequences of that action coming out from the boardroom that went to engineering. Engineering did a bit of a study, and now in manufacturing, we have to see what to do and to deal with that. So here we can see that engineering has updated the model. They've added the attachment. And now on the manufacturing side, it's our job to take the process planning and incorporate that new option into our flexible manufacturing. So because this is all digitally connected on the platform, we can take the engineering data. We can now navigate and find the corresponding manufacturing information, connect that with the manufacturing process plan that we need to now revise to incorporate this new option, set that in as a task to be worked on, and now the manufacturing engineer can do their work to upgrade that process plan. So all this, as you can see, is very simple. It's very quick. It's completely digitally connected in real time. And this is how, with everything we've just shown, the 3DEXPERIENCE platform and the 3DEXPERIENCE Twin are helping to improve productivity and agility for very efficient execution on the shop floor, which is the human theme, and also unleashing extreme creativity and innovation in manufacturing, which is the creative piece.
Thank you very much. So I think, I hope at least you got the picture. The 3DEXPERIENCE Twin will help us make smart decision making. It will help us manage the value. It will help us execute efficiently on our shop floors all those operations that we need to perform. And finally, it will unleash our creativity. So this is the kind of things we need to be able to be in the winning pack of the race to the age of experience. So this concludes this demo. Thank you, gentlemen. And actually, this concludes the first half of this plenary session.